Welcome everyone to Media City and the University of Salford building, and I hope that you're going to find this Christmas lecture of interest. The web at 25 is the topic, and we're going to explore the development of the web and some of its impacts on ourselves over the course of this talk. So let's start with some questions. So I'm assuming that you people in the room all use the web. So what I'm looking for is a show of hands when I say how many people actually have used Google for search engine. Okay, well, it's not too surprising because actually Google is currently handling 3.5 billion searches per day. Now, people looking up just about anything you can imagine on the web. Anybody bought their groceries online? You know, they're shopping, they're grocery shopping online. Okay, yeah, not as many as Google, but nevertheless a healthy number. And actually Tesco currently has a 30% share, the largest share of what is in the United Kingdom a £7.7 billion market. And Cyber Monday, anybody buy anything on Cyber Monday? Ah, that's very good. Cyber Monday, of course, this year in the UK alone brought in £650 million of online sales in the UK. Absolutely phenomenal. What about the BBC? Anybody watch television now on the web using the iPlayer service, which of course is developed in the building next door to us, if you didn't know that. The BBC iPlayer is phenomenally successful. Every year they're dealing with something of the order of 3 billion requests for programs to see on iPlayer. Anybody here into Twitter? Okay, good, good, good. Twitter, of course, is very important social media. About 500 million tweets every single day coming through Twitter. Anybody bought something from Amazon this year for Christmas? Oh, look at that. That is really almost as many people who put their hands up for Google. Amazon, of course, only exists because of the web. There is no store on the high street, which is Amazon, and every year it's a $74 billion global market. So Amazon then is an example of a company that only exists because of the World Wide Web. Now on that social media, anyone here active on Facebook? Yep, I thought that would bring out a few hands. Facebook has 223 million users in Europe and 1.3 billion active users per month globally. Huge numbers. All of this impacts us. We use it now, we use the web now to search for information. Almost any piece of information we want, people will now say, I'll Google that. It's become natural. People purchasing items online through the web. It is the standard way, increasingly, that people actually do this. And what's, I think, quite fascinating about the web is it actually started 25 years ago this year. It's 25 years old. It's the silver jubilee of the World Wide Web. So what actually brought the World Wide Web into existence? Well, this person, Theodore, or more commonly known as Ted Nelson, developed something which is called hypertext and hypermedia back in 1963. Then, in 1969, in America, the Advanced Research Project Agency developed one of the first large-scale computer networks, which actually grew to become what we call today the Internet. So the Internet was born in 1969, hypertext and hypermedia was there in 1963. And then, in 1989, along comes this man, Tim Berners-Lee. And what he sees is a connection between hypermedia and what we now know as the Internet. And by putting those two things together, created what we now call the World Wide Web. And he wrote a proposal in March 1989. Given how significant the impact of the web has been, the title is rather mundane of this iconic memorandum, Information Management, a Proposal. This is the document that is the blueprint of the World Wide Web. And clearly his managers and superiors at the European CERN Research Institute thought that this was a very important document because, as you can see here, one of them wrote across the top of their copy, "Vague but exciting." Little did they know what was about to come. So the purpose of these Christmas lectures is to try and demonstrate some of the principles of what's going on, and demonstrations only work if we get volunteers to come out and help us do the demonstration. And this is the first one. I actually want to demonstrate what is this thing called hypertext and what exactly brought about the birth of the World Wide Web. Now, Martin is ably assisting today, trying to find me some volunteers who are going to come out here and try and illustrate what we mean by hypermedia. So if you'd like to come out and stand up on the stage and take one of those and face the audience with one of these. How are we doing? One more? Oh, we got, sorry. Now if we have, yeah, that'll be fine. Okay, two if you wish. If you want to hold that. Now you're going to have the great job. I hope you're good at knitting. Right. If you just want to hold here a moment. Okay, what we've got here now is everyone here is representing a document. And those documents are the cards which are being held up. Now each of those documents has got a title, but they're all independent of each other. So if I picked on your document, the World Wide Web, it's called, I could read that document and that's fine. But I'm not aware of whether any of these other documents in front of us today have any relevance to this one or not. In other words, if I have to find every document relevant to the World Wide Web, I actually have to check every single one and form a judgment. Now what hypermedia does is allows us to create connections and links between seemingly separate documents. And that's your job. What we have here on the table are some strings. And what I'd like to do is to try to make some connections here. You'll see that we've got some hooks on each document. So if we were to start, for example, here, and this document talks about somebody called Tim Berners-Lee. Now, it just so happens the person stood next to him is holding a picture of Tim Berners-Lee. So what I can do is create a link that links those two documents together. You got the idea? Yep. Right. So let's see if we can create any more links between these documents. And you can have multiple links on the same hook if that's what we want. So we've got computers here, for example, linking to the document about computers. What have we got over here? Advanced Research Project Agency. I'll help you with that. It goes over there. Oops, there we go. Any more connections we can make? So what we're doing is we're looking for connections between these documents that link them together, and we're using string or wool here to represent those connections, those links. And these are going to be called hyperlinks because they're linking documents together.
Not long enough.
Oh no, do you want to move a bit closer? Shuffle. There we go. Now, has anybody not got a link? We could do one more just to get the point across. There's Tim Berners-Lee again, right? Okay, right. So what we've done now, whereas before, when I found just one document, it was an isolated document that had no relevance or relationship to any of the others. Now, whichever document I find, this one here about the ARPANET, it is now connected to other documents relevant to that particular topic. And these strings here are the links that connect those documents together. So if I find one, I potentially automatically find all of the others relevant to the same topic. And this is basically hypertext. And these links are what makes hypertext really valuable, because it provides the connection between seemingly dissimilar, unrelated documents. Okay, well, thank you very much. Do you want to just put the cards on the floor and return to your seats? Thank you very much. Let's give them a round of applause there for contributions. That goes the concept of hypermedia and hypertext. What Tim Berners-Lee said, there's a connection here. If those documents that those people were holding were actually stored on computers, instead of being held by individuals, if those individuals were actually computers, and those computers are interconnected by a network, the internet, then actually that concept of hyperlinks and interconnections now means that the documents stored on all of those computers somewhere out there on the internet can now be linked together to create the World Wide Web. And so Tim Berners-Lee saw how hypertext, as you've just seen demonstrated, could be combined with the concept of the internet. So you do need some other components to make it work. You need a computer of your own on which to access this network, and you need what we call a protocol to transfer the documents from the computers on which they're stored to your machine. And because we're moving documents which are hypertext, that protocol is known as the Hypertext Transfer Protocol, HTTP, which is why websites start with HTTP. Then we need a piece of software on our computer on which we can see these documents, and that piece of software is called the browser. So the browser, the protocol, hypertext and the internet, put all of those things together and you've got the World Wide Web. This is the first website that was created at CERN, and it's actually live again. So that website address, if you type in info.cern.ch, it goes to now a real version of that original website that Tim Berners-Lee put together. The computer on which that website was hosted is now on display at the New Information Age Gallery at the Science Museum at London. It's a Next computer, and in August 1991, all of the software and techniques for using the web were released into the public domain for others to use. So it was in March 1989 Tim Berners-Lee came up with his concept, and then from 1991 it's publicly available for others to use. And how did we grow from there? Well, we're going to have a look on the left of this diagram from the website Internet Live Stats. We're going to see how many web servers there are on the internet, and from our friends Google on the right-hand side, we're going to see how many separate web pages there are. So we start with one web server, the first one. In 1998, there were 1997 rather, there was 1 million web servers on the internet, and Google were indexing 26 million separate web pages. In 2000, Google measured the first billionth web page that they were indexing, and we had 50 million websites actually active, web servers active in 2004. In 2008, Google were indexing 1 trillion different web pages, and this year they index 60 trillion, and there are approximately 1 billion separate web servers on the internet. From 1991 to 2014, we've grown the number of computers on the internet serving the World Wide Web from 1 to 1 billion. We have gone from essentially 1 page to 60 trillion. And that is a huge number. But how big is 60 trillion? Well, it's huge, isn't it? Let's now do an experiment. It's a thought experiment. It's a conceptual experiment. Please do not try this at home. Imagine you're sat down in your computer at home and every second you will view a different web page to that which you've just looked at. You will do that every second, new web page, new web page, new web page. You'll do that for a whole minute, a whole hour, a whole day, a whole month, a whole year. Imagine it's possible to sit down in front of a computer and do nothing else for a whole year, but every second see a new web page. It's impossible, we know, but just imagine you could do it. At the end of that year, expressed as a percentage, how much of the total content of the World Wide Web would you have seen? And I want a brave person to open the bidding with a number as a percentage of how much you think you would have seen. So who's going to open the bidding? At the back, sir. 0.5%. 0.5%, says the gentleman at the back. Is it higher or lower than 0.5%? Lower, says the man at the back. How much lower? He's not committing. Go on, if it's lower than 0.5%, how much lower? 0.005%. Okay, how do the rest of you feel about that? Is that now about right? Is it too low? Is it too high? Anybody want to offer an alternative suggestion? Higher or lower than 0.005? Lower, they say over there. Do you want to commit to how much lower you might think it would be? Half a millionth. Whoa. Well, it's actually 0.00005% of the total web content. If you actually sat down now and for the next year looked at a new web page every second, continuously for a year, you would have achieved the magical figure of seeing 0.00005% of the total web. At that rate, it will take you 1,902,587 years to see it all. So, it's a bit of a challenge, but actually the challenge is far greater than that, because in the last 6 years, the web has grown by 60 trillion pages. So if that rate was to continue whilst you are spending time for your 1 million odd years looking at the web, in 1,902,587 years, whilst you've been reading the 60 trillion pages we know about today, the web would have grown to 19 quintillion pages in that same time. That actually means that after 1,902,587 years of every second looking at a new web page, you would, at the end of that time, have seen 0.0003% of the total. You will never do it. The web is growing and is already larger than you could possibly hope to consume in an entire lifetime, if not several thousand lifetimes. That is how big the web has become. And one of the problems we've got with the web, those web pages that were held up there, we've got a bit of an issue of how do we actually refer to them? How do we name them? Well, humans, of course, are good at characters and words. So picking any old website at random, www.salford.ac.uk, we can remember that because it's a word. www, World Wide Web, Salford, Salford University, AC, Academic Community, UK, this country. We can remember it. But actually, the computer that holds that website doesn't know that name at all. It's 146.87.137.14. Now, which would you rather remember? The one on the left or the one on the right? So the computer understands the one on the right, but we understand the one on the left. What we actually need is a way of converting between those two. And a key part of the web in doing this is something called the domain name system, which was actually in existence before Tim Berners-Lee's proposal. That was created by Paul Macapetris and John Postel back in 1983. So the DNS, domain name system, is that which allows us to use web addresses which are memorable and convert them to the numeric addresses which the computers themselves actually understand. And again, to illustrate how this is going to work, we have another little demo to show you how DNS actually operates. And for this, Martin will need 2 people at the front, and then the rest of the audience will participate. You were worried when I said the rest of you would be involved. Okay, so who would like to be the DNS server?
Go on then.
All right then. You want to just stand here? And you're going to be the person trying to find the websites. Okay? Now, there's not a lot you can do at the moment, because what Graham is doing, Graham is distributing, for those of you that receive this, you're going to get 2 pieces of paper. One is a coloured glossy piece of paper, which is the website, and the other is a piece of paper that you're going to have to fill in some details for. And what you are now, those people who have got these pieces of paper, you are the websites and the web servers on the internet. And what we need to know is what's your address. And so that piece of paper with the boxes in it is actually going to be your address. And we're going to use the address based on where you are in the room. So what you can do is count how many chairs you are from the right or the left, whichever's more convenient, how many rows from the front or the back, and fill that in. And Graham should have given you a pen to do that. It doesn't matter which one you choose, so long as we can, you should have effectively a front to back reference and a left to right reference. Now, the only thing we have to remember is their left is our right. So we're going to have to switch that round. That's a mistake I made at Birmingham last week. When you have completed your piece of paper with your coordinates in, we would like you to pass that back to the front. And if you would like to hoover up those pieces of paper, Mr. DNS server, you will collect those documents, okay? Now, this is a list of the websites which have now been distributed around the room, okay? And on that list, there may be some that you're quite interested in seeing. But the trouble is, you've no idea where on the internet the website you're interested in actually is located. And that's the problem. And that's what, hopefully, this guy is going to solve, the DNS server. Okay? So, of the websites here, which one do you want to see first?
Oh, obviously this one, the ITP.
The ITP, and that was done without any bribery at all. So, we have to ask the DNS server, could you tell us, please, where the ITP website is located on the internet? So we're going to get some coordinates. If you want to hand the piece of paper over. Now, can we go and search? Now, can we go and have a look in the room and see if we can find that website? So it's this many rows from the front and the back, and left, of course, is their left's our right. So, this person is 3 rows from the front. You want to go 3 rows into the room. And they are 7 from the left, which is 7 from our right, of course. And have we got the ITP? Right. So we've now located on the internet that particular website, and you've gone straight to it. Mm-hmm. Okay, let's pick another one and see if we can do it a second time, make sure it wasn't a fluke. What would you like next?
Facebook.
Facebook. Where's Facebook, please? Okay, do you want to go see if we can find that one? So it's 6 from the front. And how many have we got left and right?
8 from the left.
Well, this is their right. So is Facebook here? Hooray! Right, go on, one more for luck. Go on, let's do. So what we're now able to do is, without us knowing, we can go and find the website we're interested in, because this guy is doing a sterling job translating everything. So what's the next one you want?
BBC.
The BBC. Here we go. Right, now where are we this time?
So 4 from the front.
Right. Oh, I see, these are the seats. Your empty seats didn't count, did they not?
5 from the left.
But there we are.
Here, I found it.
There we go. And there we are. We've found the BBC website here in the room. Okay, so what we're able to do, DNS is able to convert the human readable name, what we call the URL, www.bbc.co.uk, into an address, in this case for convenience of the room, how much from the front, the back, the left and the right, and we, or you, were able to go directly to that website and read the documents. And that is an essential part of the web, and it's called the domain name service. Thank you very much for your contribution. Just pop those on the table there, and thank you. Of course, life is not that easy. On that model, our DNS server would actually have to know the location of every website in the world. Well, you've seen how big the web is. It would be too big a database to store. So we have to have what we call a hierarchy of DNS servers. When you connect to the internet, your internet service provider will provide a local DNS server. But if that doesn't know, so let's imagine we want to go to www.greatsite.host.co.uk. Our local DNS server hasn't ever heard of that, so it has to ask one of 13 globally positioned root DNS servers. And it says, do you know where greatsite.host.co.uk is? And it can reply and say, no, but try the UK DNS server. So we can then ask the UK DNS server, do you know where www.greatsite.host.co.uk is? And it can reply and say, no, but try the DNS server host.co.uk. So we can then try that DNS server and say, do you know where greatsite.host.co.uk is? And this time it says, yes, I do actually. And the address is w.x.y.z. And that is then given to us by our local DNS server. So actually, we don't just use one DNS server that you saw in operation there. We use several, each cooperating with each other to allow us to convert human readable addresses into actual locations out there on the internet. The other thing, of course, we want to do is to search for information. So let's just see how easy that is. Again, Martin, if we could have another volunteer who's going to try to do some searching for us. Oh, sorry, we can spread them out actually. Yes. Right, here we go. Okay, right. Remember those, do you want to come up here? Remember those 7 people we had stood out the front? They all had a web page. Those web pages are now laid out on the table. Okay, so this is what people were holding. Now, what I'd like to know is if you could tell me, because I'm interested in searching the web, and this is the web, could you just find me all the pages that relate to Bob Taylor? Let's start the clock going, shall we? See how long it takes. Remember, you've just typed in Bob Taylor, pressed return, and we're waiting for the reply. Okay, which one would you suggest is the best one to read first? Okay, so you found 2 documents. Tell us how you did that search.
You just look for Bob Taylor's name.
Okay, but did you look in every single document?
Yes.
Right, so you actually had to read every document and look to see what word was stored and read out the whole content, find the words Bob Taylor, pick them out and then pass them to me. Now, if Google did that every time you searched for something, it would take so long you wouldn't use it. So we need a more efficient way of searching, don't we? And actually, I'm going to make it a little bit harder for you because I'd like you to turn those cards upside down so that the text is facing away from you. Whilst you do that, I'm just going to explain how Google actually does it. It's the web. What lives on the web? Spiders. Let's send in the spiders. So the spiders are sent in to find all of the HTML documents that are out there on the web. And they hoover up all of these documents and bring them back to the search engine when they found them all. We send these spiders out there looking all the time for the document. They crawl all over the web looking for content. And they bring everything back and create an index. And that index is a list and location of all the documents out there on the web. So when you search for Google or any search engine on the internet, you're not searching the web at all. Actually, you're searching Google in this case as index of the web, not the actual web. So it's that index which you search, not the actual web. And so, of course, it's so much faster because Google and all the other search engines have already spent ages looking around the internet, building up this database of documents and explaining how they relate to each other, create an index, and then you search that index, which is how they're able to respond so rapidly with the results. Now, the documents that we have over there have now been indexed, and we've got here, and this is why I said turn the documents upside down, because you would think, how am I going to find anything with the documents faced away from me? This is the index which is now on the screen. And what this does, across the top, 1 to 7 are the numbers of the web pages that we've just been looking at. Down the left-hand side are the keywords that I happen to have chosen for this index. And so if you go horizontally and vertically, you will see, for example, ARPANET is mentioned on document 1 twice. We have a reference. If you see the letter T, it means it's in the title of the document, and if you see IMG, it means there's an image of that on the site. So now, if we want to do a search, all we have to do is search the index. We don't have to spend time reading all of the documents. So, how many documents? Would you like to find the documents that refer to computers? So you've got your index here. Okay. So let's find the documents that mention computers. Okay. You're not even having to read the documents now. You're just picking them up straight away, and you're finding all of these. Okay. Now, which one do you think, I've got hold of those, and which one do you think might be the one to start with? Which one?
3.
Number 3. And why did you say number 3?
Because it's got the information in the title, and it's got 4 kind of...
Right. So document 3, and there we are, proof that it's the genuine article, has computers, 4 references to the word computer. It's in the title, so this would be top of the list. And this is what's happening. And you found those so quickly. If you'd had to read all of the documents, you'd have been there for a little bit longer. And that's how search engines are able to react quickly. But of course, they're only as good as the indexing that they've done of the websites themselves. So that's why sometimes some search engines might give you a different response to others, because their indexing of those websites is different. So it's much easier to search the index, isn't it, than to read 60 trillion pages every time. Okay, well, thank you very much indeed. Let's have a round of applause. So all of these search engines are having to crawl around the web looking for all of the documents that they can find, working out how they interlink and relate to each other. But of course, the whole point of the web is the content. We don't want to search just because we're interested in an address. We want to search because we want to read what it's in the page. We want the content. And when documents started being used on the World Wide Web, they were what we would call static. And that's really what we've demonstrated here today. If I ask for a document from the web server, then basically I'm going to get in my browser a copy of that document, and it will be the same document every time. I issue a request to the web server, and what I'm going to get in response is actually a copy of the same document every time I ask for it. It won't change, it will always be the same document every time. And that is what was the web in 1989 and onwards. Fairly static, well, completely static actually, basically what we've seen here demonstrated already. But despite that, it was phenomenally successful. This graph shows the usage of the internet, and do remember the internet is the thing that delivers the World Wide Web to us. And this graph plots the usage of the internet from its birth in 1969 through to figures we have for last year. And what you see is that for most of its life, not a lot happens. And then all of a sudden, it really accelerates away. And what drives that acceleration is actually the web. The web made the internet useful to the general public. And I think this point of growth and this change in the use of the internet is best summed up by President Bill Clinton. Because President Bill Clinton, who held 2 successive terms as American president, actually said this. In 1996 he said this: "When I took office," and that was in 1993, "only high-energy physicists had ever heard about what is called the World Wide Web. Now, even my cat has its own web page." And that's what had happened. In that time, the web, the internet, had gone from being the domain of the science and engineering community in research labs and universities around the world to us, the general public. And that growth of the usage of the internet was driven by the World Wide Web. It's had a dramatic impact on the internet and, of course, on how we operate. The web then, of course, evolves, content evolves. And instead of just asking for the same page every time, actually now what happens is that the server on where the page is stored actually stores data in a database. And so when you request information, the page you get back is dynamically created from what is in the database and the nature of the request you've put in. And what you get back then is still a web page, but that web page can vary because it's built up at the point of request from the database and served to you. And for those of you that are into this sort of technology, this is the technology of JavaScript and PHP actually creating dynamic web pages into your browser. It's also the point at which we go into social media and create the blogging sites, Wikipedias of this world, news feeds, the LinkedIn social networks, and of course, our friends Facebook and Flickr and all of these social networking sharing tools. It's actually the dynamic web, what we call server-side programming and dynamic web page creation, that allowed that to happen. And that, of course, was another revolution in our use of the web. So if we can process the pages on the server, why can't we make the browser a bit more sophisticated and let it also do some processing? And we call that client-side processing. So now what happens is when we request a web page, as before, that web page is dynamically created by the server from all of its database. And when it's fed back to the browser on our computer, it can then be processed again by software running in the browser for us. So now you've got dynamic content in the server and you've got it dynamically changing in the browser at our end. And again, for those of you into the technology, this is the world of Ajax client processing. And what does that mean? Well, what now means, if you have a web page on your screen, parts of that web page can be automatically updating themselves without you having to physically do it, because there's processing going on in the background, constantly changing and updating that content. You see this a lot in social media sites. So for example, as the browser becomes more than just a viewer, it's becoming a processing engine itself. If you take something like Twitter, so this is one of my Twitter pages here, then that will be on my browser screen. As new tweets are generated, I don't have to refresh this page to see those. That section in the middle is automatically updated because there's software on the browser running in that part of the page, keeping it updated for me. So the page is really dynamic because without having to request it, the page is constantly being refreshed by the software running on the browser doing that for us. So you're probably not aware that it's happening in a sense. You're just used to the idea that that section of the web page updates automatically. It's only doing that because of client-side processing. And who says you have to use a computer? Why not your mobile phone? The growth of the smartphone has been tremendous and had a huge impact on the usage of the web, as indeed more recently has the tablet at home. So now, with a browser on your smartphone, you can read the same web content as we can with a computer at home on a desk. But you can also not use a browser, but use an app, a dedicated program that runs on your smartphone. It too can access the same web server, and now companies are able to say to you, okay, well, look at us on the web, or why don't you use our app to access our services? And that app and that website are being served in the same way. It's just a different way of doing it on the phone. So when you're running the app, it's actually accessing the same web server as though you were using a browser on your computer. And again, this has had a huge impact on our usage of the web. Ofcom said that now 57% of consumers use your mobile phones to access the web, the internet. And the average UK adult, and this was the statistic that came out in August of this year, actually now spends more time per day online than they do asleep. So now we are sleeping less in an average day than we are online. We almost don't think about being online anymore. It's part of life. We are permanently connected to the web, and we just assume we will be online accessing content. And what I want to demonstrate finally is the integration of all of this and where it's going with something that is a new development on the web, something called web sockets. Now, what we're going to do is pull up a web page. So we've got a web page coming up here. I now have in my hand a tablet. And you'll notice on this web page there is that strange symbol which is known as a QR code. The square symbol with the 3 squares in its corners. That QR code is capable of being read by a portable device. This, for example, which I've now read. I need to remember what I'm doing here. That laptop is connected to the internet, and so is this. But this is connected to the internet through 4G, and this laptop is connected through the university's network. But now what's happened is they're now synchronized. So if I want to play duck shoot, the ball that I'm going to fire is actually coming from here, not. Look at that. That's the first time I've hit 2 in a row ever. As I move this around, every time I move this, what I need to stress is there's no connection between this and that laptop. There's no Bluetooth going on, there's no Wi-Fi going on here. This is connected to the internet through 4G. This is connected on the mobile network to 4G to the internet. This computer over here is plugged into the University of Salford campus network and connects to the internet through the UK national network for universities called Janet. They both have quite different routes to the internet. They're both accessing the same web server, And what's happening is this web server is now recognizing that this tablet and that computer are now going to be linked. And so any command I do on this tablet goes off to the internet to the web server relays it back to this laptop, and it looks as though there's a direct connection between them, but it's not. It's going through the web. So now what's happening is we've got client-side processing on here, we've got client-side processing on that laptop, we've got server-side processing on the server, which we can't see. It's somewhere out there on the internet. No, I don't know where it is. And that's all been synchronized back together so that we can put these two devices connected through the web. And that's done using the latest sort of developments in technology for the web, which is called web sockets. And you're going to see a lot more of this now, this integration of devices and synchronization of devices across the web. And really, it doesn't matter how you connect to the web. As you've just seen, one of the devices was actually connected through a mobile phone network. The other through a completely different technology. It's a completely different machine. Totally different device. Totally different operating systems. This computer's running Windows. That's an iPad. It's running the Apple iOS. Different software, different means of connecting to the internet on both machines, yet the web and the internet provides that seamlessly connection between both devices so that we have interaction. And also, the time delay wasn't too bad. As I was moving my finger on the pad, the ball was visible actually on that screen fairly quickly, yet it was going off round the web and the internet to make that all happen. So more and more and more of this integration and interaction is coming, and the web browser that first came into being in 1989, just so that you could view hypertext documents, has now itself become the operating system on which people can write programs that actually do really quite fascinating things on the web. And of course, we've got a tablet and a laptop. The Internet of Things is going to connect even more everyday objects to the internet and hence the web. So that integration that I've just shown you between an iPad and a laptop, imagine any device in the home with that potential connectivity between it. And that's the vision of the Internet of Things. And it's web technology that's actually going to provide all of those interconnections. So let's just remember that the story began 25 years ago with Tim Berners-Lee looking at how hypertext and the internet could be molded together to create something which he had the vision to call the World Wide Web. And that first web page has evolved over those 25 years into technology I've just been able to demonstrate using so-called WebSockets to provide integration across devices that Tim Berners-Lee himself could not have dreamed of existing 25 years ago. It's a phenomenal story. It's a fascinating story, and the engineering and science and software, the evolution that has taken place in that time has really been quite revolutionary and, again, very exciting period of time to be involved. And it's not going to stop. So for those youngsters in the room, this technology isn't just going to stand still. It's going to drive forward. It's going to evolve. And it's actually you people who will help that go forward. So as a subject area in which to get involved for your future careers, it's an absolutely fascinating area. And of course, you've seen just by the scale of the numbers how much impact you could have on the world as a whole through these sorts of technology. Now, obviously, in a lecture of this length, we can only touch the surface of the subject, but I hope that maybe we've opened your eyes a little bit today as to what goes on behind the scenes when you type in the words into Google and press return. The DNS, the search engine, the indexes, the client-side processing, the server-side processing, the WebSockets. All of that technology is happening behind the scenes so that when you click return, seemingly instantaneously you get what you want on your screen. I think that is a tremendous success story. I think it's a fascinating world to be involved, and it's going to get even more exciting going forward. But with that, I would like to say, let's remember how it all started. There it was, the world's first website. It is still available today if you want to see it. And look at how far we've come. Thank you very much indeed.